For section 7.4, we are going to apply properties of similar triangles. And the first theorem that we have is called the triangle proportionality theorem. And that says if we have a line that's parallel to a side of a triangle and it intersects the other two sides, so in this case we're talking about the line going through EF here, it is parallel to the bottom and it's going through the other two sides of that triangle, then it divides those sides proportionately. So if this here, this side over this side is going to be the same thing as this side over this side. So they would form a proportion that way. So for example here, it says to find CY. So CY is right here and we have to figure out what that is. So since XY is parallel to BC, I can say that the sides, the two different pieces of the side are going to form a proportion. So I can say that 4 over 9 is going to be the same thing as x over 10. So I took the two sides here and the two sides here and formed a proportion. And I started with the 4, so I started with that b to x. So I have to start with the c to y on the other side. So I made those my top numbers. And then the larger pieces I made as the bottom numbers. So now we cross multiply. So I'm going to do 4 times 10, which is 40. And then I have to divide by what's across from the variable, which is 9. So 40 over 9. 9 goes into 40 4 times. That's 36 with 4 left over. So CY is 4 4/9. The next thing is the converse of that triangle proportionality theorem. And it says if we have a line dividing two sides of a triangle proportionately, then it's parallel to the third side. So if we have proportional sides, then we know it's parallel. So we have to prove that the two sides are proportional, the divisions here. So in this one, we have to verify that MN and KL are parallel. So I'm going to set up my proportion. I have the top side, so I have 21 over 42. It's supposed to be equal to the bottom. The 21 is on the top, so that corresponds with the 15. So I'm going to make 15 over 30. And to check this out, I'm going to cross multiply. So I'm going to do 21 times 30. And I'm going to do 42 times 15 to see if they're equal. And 21 times 30 is going to be 630. And 42 times 15 is also 630. So that forms a proportion. The other way we could have done this is to reduce these two fractions. 21 and 42 both have a 7 in common. So I could divide both of them by 7. So I would have gotten 3 and 6, which reduces down to 1/2. 15 and 30 both have a 15 in common. If I divide them both by 15, I would have 1 and 2. So they both reduce down to 1/2. So a couple different ways to look at that. Whichever way is easier for you works for me. So because they form a proportion, then we can prove that those two lines are parallel. Next is the two transversal proportionality. So if we have 3 or more parallel lines, and those parallel lines are intersected by two transversals, so the transversals are the lines going up and down, and the parallel lines are sideways, then they divide the transversals proportionately. So we are going to use that information here to do example 3. And it says that an artist used perspective to draw guidelines to help her sketch a row of parallel trees. She then checked the drawing by measuring the distance between the trees, and they want to know what is LN. So the trees are our parallel lines. They're kind of difficult to see there, but there's these parallel lines right here. So that theorem says that if I have 3 or more parallel lines than the transversals, which in this case would be our outside lines, cut the parallel lines proportionately. So we need to find the distance of L to N. So we need to find this distance right here. We don't know that one. So we're going to look at what we do know on that side. We know K to L is 2.6. And then we don't know what LN is. And on the other side, we know this side here is 2.4, and that goes along with that 2.6. So they're both on the top of my proportions, or my proportion here, my ratios. And then the X goes along here with these two added together. So 1.4 plus 2.2 is 3.6. And now I have to figure out what X is, so I cross multiply. So I have to do 2.6 times 3.6, which is 9.36, and then I have to divide that by what's across from the variable, which is 2.4. So I got 3.9, and these are centimeters. So from L to N is 3.9 centimeters. And then next we have the triangle angle bisector theorem, and it says an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional. So if we divide that angle in half, so both sides are the same, then the sides opposite, so in this case, in the picture, BD and DC are going to form a proportion. And those will be proportional to the side length, so AB and AC. So as you can look here, BD over DC, so the two pieces at the bottom make one ratio, and then your two sides here make the other ratio. So we have to find RV and VT. So this is showing us that we have a angle bisector because it divided that angle in half. And we know we can set up a proportion that x over 2, that RV, over the V to T, so 2x plus 1, is going to be proportional to, we started with that x plus 2, that 10 is on that side, so 10 over 14. So now we have to cross multiply. So I have to do 10 times 2x plus 1. So 10 times 2x would give me 20x, and 10 times 1 is 10. And then 14 times x is 14x, and 14 times 2 is 28. So now I have to solve this. So I'm going to subtract 14x from both sides. And then I'm going to subtract 10. I'm going to move over here. So I have 6x equals 18. And then I'm going to divide by 6. So x is equal to 3. So I have to use that then to plug in for x. So r to v is x plus 2, so that's 3 plus 2, so that would be 5. And then v to t is 2 times x plus 1, so 2 times 3 plus 1 would be 6 plus 1 is 7. So there's my two side lengths.